So far, we haven't done any calculations yet. Let's go ahead and now continue though with the hypothesis test to see where are the calculations. It's like, is this an English class? A lot of writing, right? However, we'll get to that soon. Naming the tests. Well, again, we're in this lesson of one proportion z tests. That means we're going to be using a z test statistic, and we're testing we have one sample of data, and we're looking at a proportion. So that's what we're doing now. We'll be able to compare those. Now, when we do calculations, it's either going to be a z test statistic or a t test statistic. T, remember, is going to be saved for means. And we're going to use that value, that test statistic, to give us a p value. It's called the probability value. Because we're going to have some sample data, we're going to analyze the data, and then we're going to calculate how far that data is from the assumption. And then that would tell us what's the probability, right, that we would get data like this if the assumption was true. Now, if it's a low value, then we have to make some decisions, right? If that probability is low, it's evidence against the null hypothesis. So we'll continue on. Now, we're going to calculate these test statistics, or standardized test statistic for the long way, or test statistic, right? It tells you how far away. You can see the statistic, the sample data, minus the parameter, divided by the standard deviation of a statistic, which is your standard error. And that gives you our test statistic. We'll take a look at how to do that. It may sound complicated. This is like a z-score. So it does feel familiar. It's like a z-score. It's just we're using the standard error in this case and comparing the sample data with our assumed parameter. The p-value, again, is how likely or unlikely it is to observe sample data, right? To observe sample data under the null hypothesis if we assume it's true. It's like a conditional probability. What's the probability of observing this data given the null hypothesis is true? That's what we're really doing. It's a conditional probability, but you're just not writing it that way. The result that is unlikely to happen by pure chance we call statistically significant. So when we do see some data that's statistically different, right, that we know it's not just by chance, that there is something going on, we then say the data is statistically significant. We finish a hypothesis test, step 4, with a conclusion. Once we know, right, once we know the p-value, then we can make a conclusion. The idea is if the p-value is low or unlikely to result, right, and the data is statistically significant, then there's strong evidence that our null hypothesis is wrong. And so what we're going to end up doing is we're going to end up rejecting the null hypothesis, saying that's not true. We have evidence to say that it's not true. Again, the idea is if the calculated p-value is low, the null must go. It's an informal way of thinking about it, if you want to remember. If I get a low p-value, the probability is low, then we say the null hypothesis is not true. We reject it. We compare the p-value to many times 5%, 10%, 1%, what's called the level of significance. Right? This level of significance helps us make a decision and then write a conclusion, which we'll end this video on here. Right? You make a decision. You either reject the null hypothesis, H0 is our null hypothesis, or do not, or fail to reject it. It says the p-value is less than alpha. Alpha is our level of significance. It's the value we're using. It's kind of like our chance of making an error. So if the probability is low, then we reject the null hypothesis. How low? It has to be lower than the level of significance. And then you come to these conclusions, and our conclusions are always like this. That's step 4, our concluding statement. Again, our level of significance is determined by the researcher. In general, if it's never stated or not stated in a problem, we use a 5% level of significance. That's kind of connected to the 2 standard deviation rule. So if something has a less than 5% chance, it's unlikely, right? And so that's why we get that. But some people choose even a more stringent and say, I want to be 99% sure with my answer. I want to be 95. That's kind of what the level of significance is. It's your kind of confidence interval of your rejection. So Keep that in mind and keep this little table handy.